Every smartphone, every computer, every satellite, every artificial intelligence system, they all exist because of one tiny invention. A device so small that billions of them can fit on a single chip. A device so powerful that it reshaped civilization itself, enabling technological advances we once only dreamed about. This is the story of the transistor, the most important invention of the modern age. The building block of the digital revolution. Before the transistor, computers filled entire rooms. They were slow, fragile, expensive, and unreliable, often failing in ways that could take hours or days to fix. After the transistor, the digital world exploded, giving rise to the electronics, AI, and communication systems we rely on today. Today on Top 10 Explorer, we're diving deep into the transistor, where it came from, how it's built from scratch, how it works, and why it remains the foundation of all modern technology that powers our daily lives. Section 1. Life before the transistor. Before 1947, electronic devices relied on vacuum tubes, enormous glass devices that could control electrical currents but came with serious limitations. Vacuum tubes could amplify signals, yes, but they were huge, delicate, and energy-hungry. They consumed massive power, generated excessive heat, failed frequently, and required constant replacement. Early computers like ENIAC used tens of thousands of vacuum tubes and demanded almost non-stop maintenance. Engineers desperately needed something smaller, faster, more reliable, and energy-efficient, something that could survive the growing demands of computation without breaking under its own weight. That pressing need sparked one of the greatest breakthroughs in human history, a device that would revolutionize electronics and eventually shrink entire computers onto chips no larger than a fingernail. Section 2. The birth of the transistor. In 1947, at Bell Laboratories in the United States, three brilliant scientists changed the course of technology: John Bardeen, Walter Brattain, William Shockley. They discovered that certain materials, called semiconductors, could control electrical current in a revolutionary way, without the bulk, fragility, and heat of vacuum tubes that dominated the electronics of the era. Their invention was called the transistor, short for transfer resistor. This single device could amplify signals and act as a switch at the same time, and it did so with unprecedented efficiency. It required very little energy, generated minimal heat, and could be miniaturized, traits that would redefine the possibilities of electronics. The transistor was more than just a component. They form the unseen foundation of modern civilization, enabling innovation in every field, including communications, healthcare, space exploration, and artificial intelligence. Section 4. Building a transistor from scratch. Everything starts with silicon, the second most abundant element on Earth, which is extracted from sand and purified to extraordinary levels of purity, often reaching 99.99999%. This purified silicon is melted and grown into single crystal ingots, carefully cooled to avoid structural defects. These ingots are then sliced into ultra-thin wafers, forming the platform on which modern transistors are meticulously built. Next comes doping, adding trace amounts of elements like boron and phosphorus to create positive, p-type, and negative, n-type regions, forming the crucial p-n junctions that govern transistor behavior. Using photolithography, engineers carve patterns so small they are invisible to the naked eye, even smaller than many viruses. Each layer is deposited, etched, and refined repeatedly with precision measured in nanometers. The result is a transistor smaller than a grain of dust, a marvel of human engineering, built at near-atomic precision. Every modern microprocessor contains billions of these devices, all carefully aligned to form the logic and memory that power everything from simple gadgets to advanced supercomputers. The manufacturing process combines physics, chemistry, and mechanical engineering at levels that seem almost magical, yet it is the cornerstone of modern technology. Section 5. How a transistor works. Let's simplify this amazing technology. In a transistor, a tiny voltage applied to the base or gate controls a much larger current flowing from collector to emitter, or source to drain. This principle allows transistors to act as both a switch and an amplifier. When the transistor is off, no current flows, representing a digital 0. When the transistor is on, current flows, representing a digital 1. By combining millions, billions, or even trillions of these switches, Computers perform complex logic, arithmetic, memory storage, and decision-making at staggering speeds. Each transistor operates in mere nanoseconds, collectively enabling the immense computational power of modern devices. Modern processors contain billions of transistors, all switching billions of times per second, making even the fastest supercomputers and AI accelerators possible. Transistors are, in essence, the universe's smallest and most efficient digital workers, tirelessly performing calculations that power our smartphones, data centers, satellites, and autonomous systems. Without them, AI, high-speed computing, and modern electronics would be impossible. Every chip, every processor, and every piece of digital hardware relies on this tiny, yet extraordinary invention. Section 6. Types of transistors. There are several major types of transistors. Bipolar junction transistors, BJTs, used in early electronics for amplification and signal control. Field effect transistors, FETs, operate using electric fields to regulate current. MOSFETs, metal oxide semiconductor, FETs. The most important transistor type today, found in CPUs, GPUs, memory chips, and smartphones. MOSFETs enabled the microprocessor revolution, making modern computing and AI possible. Without MOSFETs, computers would remain large, slow, and inaccessible. Section 7. Why transistors are so important. The transistor enabled miniaturization, energy efficiency, high-speed computation, mass production of electronics. It made Moore's law possible, doubling the number of transistors on a chip roughly every 2 years. It turned room-sized computers into personal devices, enabled the internet, smartphones, cloud computing, AI, and the digital world we take for granted today. Simply put, without transistors, our modern life would be unimaginable. Section 8. Transistors and modern AI. Artificial intelligence depends on trillions of transistor operations every second. GPUs, AI accelerators, and neural network processors pack billions of transistors onto a single chip. Each step of training, each prediction, each calculation is made possible by these tiny switches operating in perfect harmony. Even the most advanced AI models are, at their core, just transistors flipping on and off incredibly fast, endlessly repeating, and forming the foundation of every algorithm and neural network today. Section 9. Limits in the future. Transistors are approaching physical limits as technology reaches atomic scales. As they shrink, heat generation increases, quantum tunneling and leakage become problems. Manufacturing complexity skyrockets. Engineers are exploring new designs, 3D transistors stacked vertically, gate-all-around architectures, alternative materials like gallium nitride, even optical and quantum computing. No matter what the future holds, the transistor remains the blueprint for all electronic innovation. The transistor doesn't glow, it doesn't move. You rarely see it, yet it powers everything from radios to AI, from calculators to supercomputers, from satellites to smartphones. A tiny switch that changed the world forever. If you enjoyed this deep dive into the most important invention in technology, hit like, subscribe to Top 10 Explorer, and join us as we continue exploring the machines shaping our future. Until next time, keep exploring.